Hello and welcome to Steps to Maths, and today we're going to be looking at functions again. So a little bit of a reminder about a function. A function is a machine or a mapping that maps an input, takes some input as a value, it does something to it to create an output. Okay, so it describes really a relationship between inputs and outputs. Now, every input together with its output can make a couple. An input and an output. A couple is just two values. And we learnt that we can graph couples on a coordinated plane. So every point on a coordinate can be described by two values. Your input value, sometimes called the x value, your output value, sometimes called the y value. And using those two together, we can draw points on a plane, and often we can describe a relationship of some point. This line here describes a relationship between your inputs and your outputs. So we won't worry about the line for too much for the moment. We're going to worry about the relationship between the input and the output, but we just want to know that each point is represented by a couple, and that couple is an input together with an output. Now previously in week 5, I think, you found out that graphs that have an x squared, did the mapping of fx to x squared plus 2x minus 5 or something like that, for example, and you found out that this is not a straight line. So we wanted to know what a function looked like, a certain relationship described by the function. This is a relationship described by this function. It takes an input x and gives you an output described by this. You just put this into your calculator. Each input goes in here. You get an output for every input. And when you plot those on a graph, you put all those dots on a picture, we get this kind of picture. If it's an x squared in it, it doesn't form a straight line. And sometimes it does form a straight line. So for example, something like this, f of x is equal to x plus 2. That's just one example. Another example, 2x plus 3, 3x minus 5, minus 2x plus 2. All of these, they have an x value. They don't have x squareds or x cubed. All of these make a straight line. So on this graph, I've plotted a straight line here. So here's our straight line. Okay, that's our graph that describes our relationship. This is the graph of x plus 2. So what I've been talking about so far was just a little reminder about what functions are, that they're an input mapped to an output. Together they can form couples. Each couple can be used to represent a point on a graph, and altogether you can use that to draw pictures of your function. When you draw a picture of your function, if it has an x squared in the function, it doesn't make a straight line. If it doesn't have an x squared in it, it will make a straight line like this. So there's just going to be two questions I'm going to ask you about this function that we can find out using our function. The first question is, this is called the y-intercept. Where does it hit the y-axis? The next thing that we want to know is that when we go from any point in the graph, if we go across 1, how far we go up. And that's called the slope. It tells you how steep it is. For every step that you go right, how much do you have to go up? That's called the slope. It tells you how steep that line is. So this is two numbers I'm looking for, the y-intercept and the slope. So the y-intercept, how do we figure out where it hits the y-axis? Well, what do we know about this point? We know that the first value, our input is 0. We haven't gone left or right at all, so our input is 0, and we have to find out what our output is. So we have a function, f of x is equal to x plus 2. We know that our input is 0, so we find 0, we put 0 into it in brackets. We find that our output is 2. So in this question, our y-intercept is plus 2. That's all you have to do. You put 0 in here. Everywhere you have an x, the x is gone, and you're left with this number, which is +2. That's called your y-intercept. Once you've found f of 0, you need to find f of 1, because we're going to go across 1 and we want to know what our output is. If I put 1 in, this is what I get. So our output has gone from 2 to 3. That is an increase of +1. So our slope is +1. This might sound a little complicated at the moment, but let's just have a look at a couple of examples. And for the examples, we're not going to be using a picture. We're just going to be using the functions. So imagine we have the function f of x is equal to 3x minus 2. Let's find f of 0. Minus 2 is our y-intercept. Let's find f of 1. So our y value has increased from -2 to +1, which is an increase of 3. And if you look here, you can really easily see that this increase is going to be the same as this number here. So our slope is +3. Let's have a look at another example. F of x equals -2x plus 5. Let's find f of 0, the y-intercept. Straight away, this is going to become 0 plus 5. So our y-intercept is +5. What's our slope? Well, let's find out how much it increases from f0 to f1. If we take one step right, how far do we go up? So at f0, we're at +5. How far do we go up to? So we've gone from 5, we've actually gone down to 3. So we've gone down 2, and our slope is -2. Now, you could find out f of 0 and f of 1 for all of these. I'm doing this because I want you to understand that every time you increase your x value by 1, your y value, your output, every time your input increases by 1, your output will increase or decrease by the slope. So this increased by 1, and the output increased -2 to +1 by the slope. This increased by 1, the input increased by 1, the output increased by the slope, which was -2, so it decreased by 2. If you look carefully at these functions, you will quickly see that the slope is the value in front of the x, and the y-intercept is the other value. So I'm just looking for those two values. Give the question set a go, okay? And see if you can figure out what the y-intercept and the slope is for all of these functions. If you like, you can draw a graph. You can see that the y-intercept, where it hits the y-axis, is when the input is 0. So if the input is 0, we find the output. The output here is this point is called the y-intercept. The slope is for every step I take across how much you go up. So you could do it that way, or if you're able to, you can read it straight from the graph. Okay, so there's a couple of questions there for you. Have a go, find the y-intercept and the slope.